So as we begin chapter 5 from the text, we need to look at some key terms that will really kind of set the tone for where we go, or set the foundation for where we go from here. So first of all, chapter 5 has to deal with sinusoidal relations. Okay, and we're going to look at trig graphs, or the graphs of trig functions, specifically y equals sine x and y equals cosine x. The first definition that we need to know is something called a periodic function. And a periodic function is a function for which the dependent variable takes on the same set of values over and over again as the independent variable changes. That is a fancy way of saying a function that repeats. Okay, as the independent variable changes, so as the x values change, the y values take on, the dependent variable takes on the same set of values over and over again. So the first example we look at here, this picture, we have a heart rate monitor. And you can see that from 0 milliseconds all the way over to 600 milliseconds, we get this shape here. And then from 600 milliseconds to 1200 milliseconds, we get that exact same shape occurring again. And then again from 1200 all the way over to 1800. Okay, the yellow, the green, and the purple, that is the exact same shape. There is repetition, so this curve is just repeating. So if it repeats, we say it is periodic. Now, there is a special type of periodic function called a sinusoidal function. A sinusoidal function is a periodic function that looks like waves. So, in plain English, a function that repeats and looks like a smooth wave. And here's an example, okay? This function down here is an example of sinusoidal behavior. It does repeat, but it also looks like a smooth wave, okay? And that function is modeling Patrick's height above the ground versus time. So check this out. We can see that from 0 seconds to 5 seconds, we have this one cycle. And then from 5 seconds to 10 seconds, we get that exact same pattern, okay? So it goes from a minimum of 2 to a maximum of 14, back to a minimum of 2, back to a maximum of 14, back to a minimum of 2, and so on, okay? And that pattern looks like it just continues on forever. So if it repeats and looks like waves, it is sinusoidal. If it just repeats, it is periodic. So here's an example, or some 3 examples to look at. This is sinusoidal because it repeats and looks like waves. This one is just periodic because it just repeats. Just so you can see how that repeats. Here's the pattern that repeats. And then it starts over, okay? And then it does it a 3rd time. So if it just repeats, periodic. If it repeats and looks like waves, a nice smooth wave, all right, we say it's sinusoidal. If it doesn't repeat, that's easy. We say it's neither. All right, this function right here does not repeat. There's no repetition there. That wave is a little smaller than this one. Sorry, the waves get progressively smaller as you move to the right. So it's not repeating. So periodic behavior just repeats. Sinusoidal behavior repeats and looks like a smooth wave. All right, let's look at the function y equals sine x. And I'll just draw this from last unit. Last unit, we had to figure all of this sine of 0, 30, 60, 90, and so on without a calculator, but I'll draw the unit circle because we can figure out our quadrantal angles, our multiples of 90 pretty quick. Remember, the sine value is the y coordinate. So it would be these y values right here. 0 degrees, the sine would be 0. 90 degrees, the sine would be 1. 180 degrees, the sine would be 0. This would be 270 degrees, the sine would be -1. And then 360 degrees, the sine would be 0. Now, just for the sake of saving time, all right, we'll fill these in. You can use your calculator to fill them in if you want. I'm rounding that to 2 decimal places as well. But this is what it would look like. And you can see in quadrant 1, sine values are positive. In quadrant 2, the sine values are positive. In quadrant 3, the sine values are negative, as in quadrant 4, sine values are negative. What this curve would look like is this blue line down here. So 0, 0, 30 degrees, 0.5, 60 degrees, 0.87, 90 degrees, 1, 120 degrees, 0.87, and so on. It's important that you draw this curve, draw this with a nice smooth curve. It's rounded, okay? Don't do like this. A lot of times I see that. No good, okay? It's not pointy. It's a nice smooth curve. And if I kept going beyond 360, so 390, I'd be back up at 0.5. 420, I'd be at 0.87. 450, I'd be back to 1. And then it would start to move back down. So we can say that this function right here, this sine curve, is sinusoidal, okay, because it repeats and looks like a wave. All right, that is the curve of y equals sine x. You see all this stuff written here. I'm going to explain that in the next couple of slides. All right, we're going to talk about the period, the sinusoidal axis, and the amplitude. All right, so if it repeats and looks like a wave, it is said to be sinusoidal. So some vocabulary here. The first thing we're going to look at is the period. It is the change in x corresponding to one cycle. And that means like when does this graph start to repeat? Okay. Does it start to repeat at 6? No, because if it started to repeat at 6, it would go back up. You'd see another hump going back up. That was Bush League, by the way. This curve doesn't actually repeat until 12 seconds. So the period of this curve, it's the change in x corresponding to one cycle or one repetition. And if I calculate the change in x, all right, well, this point right here is 0, 0. This point over here is 12, 0. You take where you end up, 12, and you subtract where you started, 0. I'm calculating the change in x. It's 12 minus 0. Okay, not much to that calculation. The period is 12 seconds. Now, you can also calculate the period by going from max to max or from min to min. I'll show you what I mean by that. If I go back to this picture right here, yes, you can calculate the period one cycle, change in x. Okay, 5 minus 0, the period would be 5. But you can also go from max to max. All right, check this out. That is an x value of 2.5. That is an x value of 7.5. 7.5 minus 2.5 would give you 5. Doesn't matter where you calculate the period, or min to min. Okay? This is an x value of 10. That's an x value of 5. The change in x from 5 over to 10 is 5 units. Okay? That'll be a little helpful, a little more helpful, this information, when we get into Word problems, applications. Another thing to note here, okay, if you're not given a picture of the graph, you can calculate the period by taking 360 degrees and dividing it by your b value. Now remember the parameter b, that tells us about the horizontal stretch, okay? It means it would be horizontally stretched by a factor of 1 over b. Same rules apply as what we were doing before. So if you're given a picture of the curve, you can find the period by calculating the change in x. If you're given the equation, you can find the period using this equation, 360 degrees divided by b if you're working in degrees, or 2 pi divided by b if you're working in radians. That's if you're given the equation, not a picture of the graph. All right, and if we erase this, we can see the period is 12. Next thing we need to know is the sinusoidal axis, right? Sinusoidal axis is the horizontal line halfway between the local max and local min. A lot of students are pretty good at just looking at these, right? And figuring out what the halfway mark is or what line represents the sinusoidal axis. But there is a way to figure out halfway between the maximum. So the maximum would be this red point. The height would be 2. I'm reading the y-axis. The minimum would be this low point. Okay, the y value there would be -4. Halfway between the two, we take our max and we take our min, we add them together and we divide by 2. So max was 2, min was -4. Add those together. You've got 2 plus -4, -2 over 2 equals -1. Notice where the sinusoidal axis, the horizontal line that cuts the graph in half, I drew it at a y value of -1. It has the equation y equals -1. So when they ask for the equation of the sinusoidal axis, since it's a horizontal line, it will always be y equals, and then whatever this calculation works out to be. Should be noted that it's equal to the vertical displacement too. So if the y value, or sorry, the sinusoidal axis is at y equals -1, k, your vertical displacement or your vertical translation, is also -1. If y equals 5 is your sinusoidal axis, k value would equal 5. That's your vertical displacement or your vertical translation. Those two things are equal. Next definition is the amplitude. It's the vertical distance from the sinusoidal axis to a local max or a local minimum. The amplitude is stated as an absolute value. It means it's always positive. So in this diagram, all right, my max is the same picture as the last page. My maximum is still at a height of 2. My sinusoidal axis is still at y equals -1. The amplitude is the vertical distance from the sinusoidal axis to that local maximum. How many units did I move up? I went from -1 to +2. I went up 1, 2, 3 units. The amplitude would equal 3 in this particular case. Same thing here. If you went from the sinusoidal axis to the local minimum, all right, you're going from -1 down to -4. You went down 3 units, so don't get confused. Don't say that the amplitude would be -3. Just remember that the amplitude is always an absolute value. So absolute -3 would be 3. Amplitude is 3. It's the distance from the sinusoidal axis to the local maximum. So to recap, period is the change in x corresponding to 1 cycle. All right, so figure out where it starts to repeat. So take this x value and subtract this x value. Sinusoidal axis is the horizontal line halfway between your max and your min. This time we're talking y values, your maximum y value, your minimum y value, add them together and divide by 2. That will give you your sinusoidal axis. Since it's the horizontal line, you have to write the equation as y equals. It is also equal to your vertical displacement. And finally, amplitude, the vertical distance from the sinusoidal axis to the local maximum. Sinusoidal axis was at -1, maximum was at 2. That means I had to go up 3 units. The amplitude would be 3. So to summarize, here's that curve, this y equals sine theta. We graphed it in the beginning, all right? Notice I didn't go with the 30, 60, 90. I just went with my quadrantal angles. So 0, 0, 91, 180 comma 0, 270 comma negative 1, 360 comma 0. The period is the change in x corresponding to one cycle. So take that x value, subtract this x value, 360 minus 0 equals 360 degrees. The sinusoidal axis is halfway between the maximum and the minimum. So to find halfway between those two things, I take the max, 1, I add the minimum, negative 1, and then I divide by 2. So that gives me 0 over 2, which is 0. Remember, the equation of the sinusoidal axis would be y equals 0. The amplitude is the vertical distance from the sinusoidal axis to the maximum. Sinusoidal axis was at y equals 0. Okay, that's this line right here. The maximum is at 1. That is 1 unit. Means the amplitude would be 1. Okay, so that is the information for the graph y equals sine theta. Here is the cosine curve. All right. And again, if we look at our unit circle before, this is all filled in for you, but if we draw our unit circle, put our x and y axis on, again, label those points 1, 0, 0, 1, negative 1, comma 0, 0, comma negative 1. Remember from last unit, this would be 0, 0. And think of your quadrantal angles. The cosine value of 0 degrees, here's 0 degrees, is 1. It's the x coordinate. The cosine of 90 is 0. The cosine of 180 is negative 1. The cosine of 270 is 0. The cosine of 360 is 1. All right, that's what it is. And there's the cosine of 30, the cosine of 60, and so on. And just to prove a point from or something that we learned from last unit as well, cosine is positive in quadrant 1, positive in quadrant 4, it's negative in 2 and 3. There's what your cosine curve looks like. And if we kept going, all right, the cosine of 390 would be 0.87. The cosine of 420 would be 0.5. The cosine of 450 would be 0. So this curve would start back down again. It would go to a minimum of negative 1, and then it would go back up to a maximum of 1. It just keeps going back and forth. All right. The y values take on the same set of values as the x values change. So this is also a sinusoidal function. It also has a period of 360 degrees. So look, I took this x value right here, 360, and I subtracted this x value here, 0. The sinusoidal axis is halfway between the max and the min. So halfway between 1 and negative 1 would be 0. And the amplitude would go from the sinusoidal axis to the local maximum. A cosine curve is also a sinusoidal function as well. Okay, some people think that just because it says sinusoidal, it has to be a sine curve. It's not true. A cosine curve also is sinusoidal. And these guys right here, these are the curves. These are your base functions. These are the guys that we are going to transform as we get moving forward. Just keep in mind, all right, that we don't always work in degrees. Sometimes we work in radians as well. So these might not always be in degrees. They could go into radians as well. And we'll do both. We'll sketch curves in both degrees and in radians. So same thing, all right? These are the 5 points. Like when we get into transforming a sine curve, these are the 5 points that you're going to transform. When we get into transforming a cosine curve, these are the 5 points that you're going to transform on the cosine curve. With a cosine curve, it's kind of shaped like a valley. It starts at the maximum and moves downwards and then back up to the max. So it goes from max to min to max. That is a cosine curve. A sine curve starts on the sinusoidal axis and moves up. So it goes from sinusoidal axis to max to sinusoidal axis to min to sinusoidal axis. And don't forget, we'll get into reflecting these in the x-axis, and we'll move them, translate them vertically, translate them horizontally. In this unit, they call that the phase shift, but we'll get into that in the next video. Just study these, study the definitions, all right, and that'll be your homework after this video. These are the points that we will transform, and that's where we're moving in the next couple of videos.